site, but anyway. Look, thanks everyone for coming. Last talk of the day. We're going to talk about something a little bit different than what we've talked about today. We're going to talk about incidents. We're going to talk about learning from incidents. So my role at Seek for the last 5 years, I have looked after our platform engineering team. And we are an operational team. We once used to deploy and support absolutely everything at Seek. We thankfully don't do that anymore. But incidents are a large part of my day-to-day role, be it looking after team members, dealing with incidents, be it actually resolving incidents myself, be it facilitating incidents, postmortems, thinking about them and reviews. So over that journey, had a lot of time to think about how we approach incidents and more importantly, how we do them better. So that's what my talk is going to be about today. So yeah, hopefully you enjoy it. So a little bit about Seek, for those of you who don't know. By the way, I can't see my presentation up the front here, man, as well. So I'll just stand over here. We've actually been in business for 22 years. So we were an original startup company in Australia, one of the first actually ever, and still in business today, which is pretty awesome for an Australian company. And we are also still the #1 job site in Australia as well. We run almost all our production workloads now in AWS, and we also, across 160 accounts, which is probably about 150 more than we need, but that's just how many that we have. And we ship changes to production about 1,000 times a month now. To bear that in mind, about 6 years ago, we're doing about 2 times a month. So I have no doubt by the time I finish talking to you, something in our production environment will be changing or has changed and may have even broken for all we know. There's an important point I want to make at this presentation, and I hope that you'll remember by the end, and that is things break and we should expect them to break. Why? I'm going to take you through this. We're going to look back at incident learnings back when we were firefighters, which is generally when we would just run around and try and resolve incidents, pour water on the fire, try and put it out, and then go to the next incident and the next incident. We're then going to look at how we originally approached trying to understand incidents, and more to the point, how flawed they were, and also the techniques that we used as well to resolve them. We're also then going to discuss how we can support people better, introduce a term called socio-technical systems as well, and then go into how we support people a lot better. And lastly, I'm going to briefly cover on resilience engineering. I'm not an expert on resilience engineering, I want to make that really clear. But I'll sort of go through a little bit of this as well, so you can hopefully, it can lead you on a further research if you like. So about 6 years ago, we used to have a very dysfunctional way of building and shipping product. We had product teams that operated in silos. They pretty much lived on an island unto themselves. Our operations teams lived on another island. And they were pretty much responsible for building the code, and operation teams were responsible for deploying the code. As you can imagine, my team hated deployments because they were grenades that set our production environments on fire because of this dysfunctional model. Our delivery teams really had no idea how production systems worked. Therefore, a lot of their code just was not suited for production, or at least the production at the scale as the site was growing. So often the monitoring system would go off all night long, and the worst monitoring system of all, which was the customer monitoring system, would go off as well, and sometimes it still does. And we really hate it when that happens, because the last thing you really ever want is your customers telling you you've got a problem before you actually realise it. That's rather embarrassing, and it does happen. So we're here to talk about learning from incidents. So from that model, the only learning, if there was any at all, was actually in the minds of the operations teams. They're the only people that knew it. The delivery teams absolutely had no idea how to learn from incidents. They pretty much only know if someone in the operations teams absolutely cracked it at them because they completely took the site offline. Mark, I swear I didn't steal this from you earlier, but mine's got animations, so I just want to point that out. Basically what I'm trying to say here is that the rest of Seek was completely ambivalent to what was going on. Thankfully, it's not like that anymore. So in this day and age, we kind of feel that we've got this. We don't consider ourselves a poster child for any organisation that claims that they are the most purest DevOps culture company in the world, but we talk about this a lot. We talk about this so much that even having the concept of a DevOps team, a DevOps practice, just stopped making sense to us. It literally became, that's just how we do it here. So we kind of feel that we've got that. We demolished most of our silos, they're all gone. We believe in teams that own what they build. So from idea right through to support, that's contained within the team. We don't like to have separate operations teams. We don't like to outsource things outside of the team. We want the team to collaborate and own what they do. So we like shipping quite regularly, continuous review pipelines. That's pretty much the standard. That's what you do if you're going to be shipping product to production. We like it to be automated. We like the test to be automated. We like A/B testing. We like blue-green environments. It also means that our tech stack is rather diverse now than it used to be. We used to be purely a Windows shop about 6 years ago, but the world has changed. And that's a really important point to make here. There is a flip side to all this goodness of autonomy, of freedom of text selection, of putting developers on pages, as someone once flippantly remarked to me, assuming that most devs all of a sudden know how to manage a pager and operational support calls and incident escalation. The reality was our environment became much more complex from doing this, and our ability to adapt and learn from failure did not keep up with it. I'm going to give you some examples of why that happened and what was sort of the catalyst for us actually starting to look at incidents more. So, to start with, you have one single autonomous team, they start building lots of services, the cute little robot's meant to be a service or a system. That worked out really well for us. So then we said, cool, let's keep doing this because that works really, really well. And while we're at it, why don't we just keep out building more and more of these teams? So eventually we get to a world where we have lots of systems now. We have lots of small APIs, large APIs, teams dumping stuff all across AWS accounts absolutely everywhere. What this means when we're trying to handle incidents is that it started to change because we're no longer doing an operations team anymore. So that knowledge now starts to become both localized and it becomes distributed. So localized for management in the teams and distributed across the board, but no one oracle like in the old days in a silo knowing how everything hangs together. The other point I'm going to make about all of this with complexity as well is that no one person anymore can know how Seek hangs together. 6 years ago, anyone in an operations team knew our servers pretty much down to their IP addresses. That doesn't happen now, and I'll explain why later. The other point here is that when we talk about a lot of this complexity, when we talk about more automation, more autonomy, more decentralization, doesn't mean you get rid of complexity. It means you move it around. So that complexity doesn't go away. It may become easier to handle, but you haven't actually gotten rid of it. Byproducts of all this, lots more integration points, lots more tight and loose coupling between those integration points. Some systems are highly dependent on other systems being up all the time with very strict amounts of latency because they might be part of a very large call stay check. Others can maybe cope with it. Localized decision making starts happening more and more. Change is not publicized. We don't do change approval boards. We haven't done them for years now. The teams own what they build. They change things on a very regular basis. And what has led to, and from our analysis, is what we consider what we're now calling emergent behaviors. So this is what happening is that when someone will change something somewhere, around the same time as someone else is changing someone, around maybe the same time as someone's deploying something, these two very things can link up and cause an incident. And we started noticing this more and more, and we started noticing a lot more around 2017. In this month alone, we had impacted over 10,000 customers directly using our site, and we had a combined total of 18 hours of outage. Suffice to say, this wasn't popular. For those of us, myself, who from a long operations software engineering background, that whole notion of the black swan event, when basically everything's going to go to hell, it's like it's about to happen. We could feel it. There were people in teams going, something bad is about to happen. There is just no one seems to be knowing what's going on. And of course, it did happen. So our old friend Windows DNS, I've never in my life seen issues with DNS as much as I have in the last 5 years. Windows is generally pretty good with DNS because Windows Server caches DNS, and we had our DNS servers running in our data center at the time in 2017. Around the same time, all the teams are building things in AWS. But these teams are configuring their VPCs to go back to our data center for Active Directory because they want to resolve back to the production environment because we still had a lot of production systems back then. Unbeknownst even to Microsoft, Windows Server 2016 released with a flaw in DNS recursive lookups. It was patched, but we, in a panic to patch of the WannaCry virus, we upgraded DNS at the same time because, hey, we just needed to do that. Recursive DNS lookups failed. To cut a long story short, this happened. We had 12 hours of continuous outage in one single day. As you can imagine, our managing director was pretty brief and to the point about what the hell is going on in terms of the fact we have got customer service leads going absolutely mental, inbound is flooded. We actually had this really funny scenario, we had this big war room and developers were literally coming in, because they didn't understand that, but doesn't DNS get cached? No, not in Linux and not on Docker and not when you're running Mono and you're running .NET on all of that. That doesn't work that way. So, and even when we could code host files, their systems would come up, other systems would see them, flood them, DOS themselves, rinse, repeat, rinse, repeat. So it took us 12 hours to get everything back online. As you can imagine, managing director's response was then sort of pushed down onto the directors to basically say, we're having a huge amount of incidents, you're not in control. You need to be in control. Because if you're in control of incidents, then you probably won't have them. Interesting theory. So, the proverbial rolling downhill was enacted, on a lot of our engineers, to a point where, we did one good thing. We started doing incident postmortems. We'd rarely ever done them unless something was really, really bad, but we decided to make this a practice. Anytime customers get impacted, we would do a postmortem, which is a good start. But we focused heavily on the root cause in the postmortems, and we were encouraged to use the 5 whys investigative technique to use them. I'm going to explain later why these don't really work in a very complex system like ours. We did collect a lot of data, but a lot of it was lagging data, or lagging indicated data. So in terms of knowledge, we didn't really gain any knowledge from this information. We were purely just looking at the outputs of the incident. We weren't really trying to learn from them all that much. The other thing is that when we actually brought people into postmortems, we would generally ask them questions like this, and we would generally presuppose questions of systems like this. In other words, this shit was going on constantly. It's almost like that scenario where it's like, it's a perfect 20/20 vision in hindsight. How could you not have noticed that? Why on earth didn't you test that? Why didn't you write a unit test for that? Don't you know that you should be doing things like this? These were some of the questions that came on. So for a lot of the engineers who'd literally been thrown pages, literally some maybe only a month ago, and were not used to dealing with this, they really struggled with that. And then we called them in for a meeting once a week, the incident review meeting, which we still do, but it's much better now. But these teams would get very localized action items. So we weren't interested in looking at more of the broad issues. We were just focused on what they did wrong. Add another monitor for this. Fix this bit of code here. Add some more redundancy in your API. Go and hassle our AWS TAM or SA on why this doesn't work. In other words, we were focusing on the people as the problem. And we were purely only focusing on the people. And that actually prejudged even the way we greeted people into these review meetings. And we would actually greet them with comments like this. Because everyone was under pressure. We had to be seen to be in control of incidents. So as you can imagine, people approached the meeting feeling like this and left feeling like this. Not great for psychological safety. And some months though, everyone thought it was working because our incidents went down. Did they really go down? I know for a fact in some cases they probably didn't, but teams were terrified of actually, and so if no one actually noticed, they'd probably try and hide it. The reports upwards went out really well, and occasionally if we did have months like this, there's sometimes an email would go out saying, hey, this is really working, everyone's doing a great job, clearly our systems are more reliable. Or are they? So here's an interesting point. Sometimes it would take the next day. I think the record was about less than an hour when that email went out congratulating everyone, and nope, we had an incident. And some team might have even gone nuclear. So what is this telling us? One, it's telling us that the amount of incidents that you are having or not having or perceived to be is no indication of the reliability of your system. But we're talking about learning. So in the great presenter tradition, I'm going to quote someone famous who's not my own words. So I think John mentioned John Allspore earlier, but this gentleman is a fantastic person to follow on Twitter. He's really big in resilience engineering, ex-CTO of Etsy, I think co-founder of Adaptive Capacity Labs, and also the author of the Stellar Report, which others have mentioned and which I highly recommend you read. So we weren't really learning anything from our incidents, and when we were trying to approach it, we're looking at the people and the system as separately. We're seeing these as separate problems that need to be managed. And it started occurring to some of us that, well, why aren't we actually looking at the interrelation between the two? We kind of see humans and systems and cross this boundary. Why aren't we focusing on the boundary? Why aren't we looking at that as well? And if, realistically speaking, incidents are a very small fraction of time when things go right, why are we spending so much time focusing on incidents? Why aren't we focusing more on when things are going well? Interesting questions. And a lot of this may actually, and so I'm going to sort of be a bit speculative here, but I'm going to sort of flip all this around to understand why do we think about incidents the way that we do, or at least how we traditionally have thought about incidents. So, if we go right back, if we cast our minds right back, has anyone sort of heard Taylor's theory of management? Does that name ring a bell? Some people? John, yes, I'm sure you wouldn't have heard of this. So Frederick Winslow Taylor, he's generally credited as being the world's first management consultant. He worked in factory, I think a steel mill in America in the late 1900s. He was also apparently an awesome tennis player. But he wrote this book. I'm not an expert on this book, but it's a very interesting book because Taylor was looking at ways to apply the scientific method to analyse how workers worked in factories and mills and to basically manage them so meticulously that they literally become a cog in the machine. Because back then, machines were generally pretty static. They just did their function, they were built, therefore the only parts that were unpredictable were generally the worker. So if we can scientifically manage the workers down, then ultimately we probably won't have assembly line failures. And management role, pure and simple, enforce it. So when we sort of think even our own organisations, we think micromanagement, we think command and control, you can probably trace it back to this gentleman here. Or more to the point, it's just that for a lot of us, this is how we grew up in organisations. I'm not going to go too far on this. I'm going to just keep one thing in mind though. This is what Taylor was all about. Work as imagined equals work as done. So that means that the person sitting up in the glass-walled, powdered glass wall at the top of your building, the way that person imagines work's being done down on the floor, it's the same. I know how that machine works. And how do I know that works? Because I've got a paper trail. I've got a series of processes, and if everyone follows the process, then no one gets hurt and everything gets done. So, funnily enough, and I never used to think I had anything in common with both my grandfathers, who were both factory workers, one in Belfast, one in Moorabbin in Melbourne. But they used to work on punch clocks. They worked like this. And when I entered the IT industry in the late 1990s, I was told that my measure of productivity was this, the lines of code per day. When I worked in offshoring companies, it was the same thing, but our offshore developers, they produce more lines of code per day. They're more productive. Therefore, they must be better. But as complexity grew in software engineering, as we all know, we start doing things like waterfall method, and then we force people to go through this kind of crap just to get a small production change out. I'm clearly not the only person in the room who's had to go through this. Any victims of CMMI level 5 in the room? Anyone ever had to do that? Yeah, here we go. All right, my people, this is what I'm talking about. So this is the extension of it. So where does this thinking come from? It's based on linear thinking, which is fine for an assembly line. But when we think about incidents, when we take the linear thinking approach to incidents, these are the kind of things that we do. We see an incident as a chain of events. This happened, and that happened, and that happened, and there's your incident. That's it, just a single chain, one line. You can draw a distinction between the two. So when we want to find it, we'll generally isolate it down to a single origin of failure, and so that way we'll see a one-to-one relationship between cause and effect. So at this point, I would highly recommend reading Sidney Decker's book, Drift into Failure, if you haven't read it. He devotes about 3 chapters of this around Isaac Newton and Henri Descartes and that kind of scientific thinking that influenced a lot of us. I won't go too much further than that. But the point is, a lot of people and a lot of companies will relate it down to human error. So one of the things that always just really gets my back up is some company, which I think it was the census fail, I think it was blamed on operator error. Really? That's a great way for an entire organisation, entire tiers of management to go, not our problem, it was the person down there on the floor who zigged when they should have zagged. So this is where that predisposition comes from, and if you think about the example I painted earlier with Seek, we were almost doing exactly the same thing. Toyota in the 1950s, we like to talk a lot about Toyota, but Toyota was actually the company that introduced 5 whys and root cause analysis. At least my quick summary on that from Takichi Toyota, who quoted this. So if all this linear thinking and all this based on early 20th century, mid-20th century thinking, we start going and we can go to the dominoes effect, the Swiss cheese model, all these kinds of theories. The reality is 60 years later, how on earth can this possibly apply to the systems we've built? So right now at Seek, this is modern complexity on a Seek scale. We are not the scale of a large American tech company or a bank or anything else. But this is just Seek right now as I'm talking to you. We have over 1,500 AWS EC2 instances running right now. We have over 1,000 Lambda functions running right now. Over 200 RDS databases and over 8,000 S3 buckets. That's our platform right now as it stands today. As mentioned earlier, 160 AWS accounts. We have over 2,000 active GitHub repos and over 30 teams working on this. So this is complexity at a modern scale. Our systems are API or event driven. That's how we interchange information, which therefore means they can be loosely or tightly coupled, growing to the nature of teams and the complexity, which ultimately means our changes are unpredictable and not all integrations can even be known. So this is a reality that we live with, and this won't go away. We could stop everything right now and we could go and document everything and it will go at a date, and I would estimate maybe 5 minutes. And I know some people like to quote sort of the pulling the and-on cord method of the Toyota lean manufacturing method. I can't do that at Seek. I can't pull an and-on cord at Seek. I'll probably blow half of it up and I won't even know. So, why does root cause analysis fail? I'm going to give you a very simple example here of why, if you're doing this kind of stuff, just change the term. Stop using root cause analysis. On the left, we've got a customer. And this is how information gets to a customer. This is actually modeled on actually how some data gets to our customers. You can think of each of these green dots as an API, a database, an S3 bucket, I don't know, an SQSQ or whatever. Any normal day, sometimes things degrade. Sometimes they may degrade briefly because of a deployment. Sometimes it might be a change that may have just introduced some latency that was unexpected. Sometimes that degradation can start pushing itself up through the call stack. That can happen sometimes. There might be a few timeouts, but it's handling a retry, no errors come about. But then what happens on some days when a few things start going wrong? Maybe that deployment went really bad and it overwhelmed something. Maybe somewhere else, maybe in a particular region, we started getting a bit more latency than we planned retrieving data from S3. Maybe, who knows? But what it'll do, it'll start pushing degradation up the stack. And then eventually at some point, something's going to get overwhelmed. It'll overwhelm something else, everything gets degraded, and you guessed it, we now have an incident. If I was to follow the 5 whys and root cause analysis method, this is what I'll probably do. I'll start here, I'll go here, this looks red, that looks red. Ah, there it is, I found the problem. Can anyone see what's wrong with this right now? Anyone? Yeah, a few? I'm only looking at 25% of what are the contributing factors to an incident. What about all of this? What about even the yellow ones? If we follow this pattern every single time, and so we have similar incidents, I would hate to be the person in that team or the people in that team. You are going to feel like everyone's local recency bias is going to constantly keep coming back to me saying, this is the problem. I'm not saying root cause analysis is bad, by the way, but we are not building cars at Seek. We are building a highly complex software system, as I imagine almost all of you in this room are doing at the same time as well. So ultimately, if you're using this, I would encourage you to start thinking more about, there's a great blog post recently, The Myth of the Root Cause. That's one that immediately comes to mind. It's a great read and I recommend you read it. So this is what we've observed when we stop thinking about it this way. Namely, we know that, as mentioned earlier, localized management of incident happens as complexity grows. We know that our systems evolve independently and that they don't resemble assembly lines. So why on earth are we taking a linear thinking systems approach to doing that? And therefore that means if we want to try and maintain the relationship between management and versus the work that's being done, that is just a total waste of time and it would probably slow us to a crawl at this stage. So how do you get better at this in your organisations? These are some of the things we're doing. Firstly, you can definitely look at your systems monitors. No doubt all of us are monitoring our systems, that's great. But how many of us are looking at our people and the pressure they're under in their day-to-day roles? Are we actually factoring that in? Are we looking at how they were feeling before, during or after an incident? Before an incident, are people being pushed under a deadline? Are they suffering from fatigue? Do they have a newborn baby at home and they're not getting sleep? Are they not generally operating, with their full faculties? Is there a lack of communication? How are they feeling after it? Do we really want to drag them through this really complex, stressful post-mortem meeting or some review meeting when they're feeling that anxious and stressed because they may have just patched something and they're just hoping they can get another change out before it breaks? What's the culture like in the teams? Do they have a culture of shooting the messenger? Do they have a culture of burying the messenger? Everything's fine. This is fine thing. I think someone mentioned earlier, the dog and the cup, the coffee cup. Or do they embrace the messenger? If some of you are thinking, that sounds familiar, yep, I actually did borrow Westrum's organisational culture model, but this is the kind of things that you need to look at when you do the teams. Sometimes before I've even done a post-mortem, I've actually reached out to some members of the teams. If I've known, I've got an inkling that this is actually a contentious area, I'll actually go and talk to them first. I'll say, how are you feeling? Is everything all right? Is there anything we can do to support you? You know, were you up all night? Should we postpone this? Should we do this another day? Can I just get some information off you now, rather than just try and slam them after they've been up all night? The next thing is the post-mortem itself that I talk about. Two things. A post-mortem is not a blame session or a witch hunt. It is absolutely none of those things, so please do not do that. Keep them as blameless as possible and focus on the information you're trying to get out of it. First and foremost, it should be about supporting your people, analysing contributing factors, building timelines. That's generally one of the ways we do it. I know there's some conjecture around whether that's the right way to approach, but it seems to be working for us. And look at it across your customers, your people, and your systems. Don't just look at your people as the problem. Don't just look at your system as a problem. There's a reason why that system exists in the first place, and the decision making was probably within the organisation itself. When you're running a post-mortem, it really helps if you have a scribe and a facilitator. So where the scribe is writing notes, taking note of the conversation, filling in various details. If you're a facilitator in a post-mortem and the incident is generally rated that of like a software engineering incident, some issues with code, it's really good to actually get someone who understands software engineering to be the facilitator that is completely objective. The reason for doing that is because the facilitator is able to put themselves in the other people's shoes. They can see it from their perspective. They've been there before. Generally, some of our facilitators at Seek will generally be someone like myself, who generally sort of straddled software engineering and operations roles for most of their career. We kind of can get an inkling of what they're going through and what they understand. And actually, when you get this information, don't just get all the lagging indicators to try and produce a report to say how great incidents are this month. Start looking at the patterns and the themes. Find out where you need to focus. Where are some of the more broad themes that are occurring across your development teams? So don't try and look at just things completely in isolation. Even from doing this at Seek, we've found some really cool stuff. Namely that some of our teams are really starting to think more about the products they build. They're starting to think better about building redundancy into their systems. They're starting to realise, you know what, we can actually make this better. We've learnt from these incidents. We've had these really good conversations where we've actually gone, you know what, yeah, this is great. We learnt something from here. We still balance it with delivery speed, but ultimately we build a stronger system that hopefully delivers more value. The other benefits that we found is that now we actually have teams that actually focus on building blocks. So building shared services across AWS accounts, specifically in areas like this. We don't need absolutely every AWS account to have its own Nginx routing stack. That is really not necessary. So what we look at, is building more of these common services out, but keep them well documented. I was really happy. One of our teams recently leveraged the transit gateway and shared VPC model. They actually built tutorials for everyone else at Seek. Like it's actually like a classroom. So they're thinking, I'm not going to just take all this complex stuff and bury it in a black box just somewhere only 3 people know about it. I'm actually going to think about teaching people how to do it. That's something that just never used to happen. One of the best things that came out of this as well, starting to change his approach, was that actually one of the engineers pulled me aside about a month ago and actually said, you know what, I'm actually really happy that we've started to change things. I actually feel supported. I used to dread coming to these incident meetings. I used to hate it. I used to feel like I wasn't supported, and now I do. So I think that's really important, because what that means then is when people feel like this, one, they're more open, they're more honest, and they're more transparent. They actually want to share information. And what we're trying now is to get a culture going at Seek that hopefully my vision for success one day is people will opt into postmortems and things like that, even if they had nothing to do with it. Because this is a learning opportunity. This is how I can actually start learning things. You know, when we think about DevOps and we think about, you know, many of the practices that flowed from DevOps, be it site reliability engineering, chaos engineering, these are foundations on a learning culture. This is about learning how better to instrument, monitor, manage, and prod and understand the vulnerabilities in our systems as well. Incidents are another great example of how to do that. The other thing with this renewed confidence is these old sacred cow systems, those old systems no one dares touch, are being targeted and destroyed. I honestly thought one day we'd never get rid of BizTalk at Seek. I really did think that, and it finally happened a month ago. And I was very happy. In fact, we turned everything off in our data center about 2 weeks ago as well. for all that old stuff. And for many times people didn't want to touch it. One, they were terrified of break, and two, they were terrified what they'd have to go through when it did break. So even just this alone encourages people to think more about it, learn more about it, and deliver greater value. So, summaries up from this. What we now know, what we've observed, what we now know, complexity does not decrease. To borrow straight from Charles Perrow's fantastic book from 1983, Normal Accidents, feedback loops will be unintended. So emergent incidents are reality. As your systems become more complex, you will start having these behaviours if you're not already. Your people are actually the flexible and adaptable parts of your system. They are not inefficient, they are not unpredictable, they are not untrustworthy. No one, I don't personally believe anyone comes to work to do a bad job. No one really wants that stress. And lastly, your incidents, as I mentioned earlier, are the learning tool. And if we start doing this really well, and this is sort of a bit of a call out, I think, to our industry as well, and for all of us in this room, when we start thinking more about resilience engineering, and if we can start doing this better in our organisations, we think about how we can continuously engineer resiliency into our systems. There is a huge amount of information on the internet on resilience engineering. There is an abundance at the moment still, freely downloadable white papers and a number of publications. I would encourage a lot of you to go and look at this if you're interested in learning more and adapting to incidents. Generally, you can think of it in 3 words. The ability to sustain, capacity to adapt to foreseen and unforeseen events. Generally, I think it was David Woods who quoted it that in a brief summary, but ultimately that's what we think about. And more importantly, it's a field and it's a community. It's not a thing. It's actually in multiple disciplines. Software engineering, IT is not the first to do this. It has origins in other industry, be it aviation, be it healthcare, even nuclear power, for all I know. It's not new to us, but it is starting to become more of a thing and something that, noticing that more and more people at conferences like this are starting to talk about. The important point also, it's what your organisation does. You don't have it. So you don't just have resilience engineering, it's something that you have to do. It becomes a practice. So to understand resiliency, first and foremost, it's not a tool, it's not a process, it's not a fancy management consultant that's coming to tell you how to do everything. So I'm just putting it out there right now, vendors in the room, please don't start saying this is a resilience engineering product, like you call things a DevOps product. It's not true. Thank you. I just hate that term. If we think about resiliency, there's actually a lot of great examples in nature. We're fortunate. We live in this amazing country with these beautiful trees. They are bushfire, drought, and flood resistant. They're incredible trees. I have about 20 on my property where I live, and I love them. Our own skeletons are amazing. Our bones remodel themselves all the time. They break down, they rebuild, they break down, they rebuild. They can absorb huge loads, and they can reknit themselves back together. But this is in nature. How do you engineer resiliency in nature? The reality is nature's had plenty of time, it's had millennia. But unfortunately, for a lot of these beautiful gum trees, they can't jump out of the ground and run away from a chainsaw. So they can't adapt to a lot of these unforeseen events. When we talk about things like climate change and we see species dying out, this is what's happening. So how can we engineer for this resiliency in the systems that we build? Sum up, this is my last slide, I promise. You can't wait for it to evolve naturally. It has to become an ongoing practice. And therefore that means you need to create environments in your teams and the conditions where they can sustain that adaptive capacity, where the work is done. Not where it is imagined, but where it is actually being done. You want to be able to learn from incidents as much as possible. They are a normal byproduct of complex systems. Remember what I said at the start, we should expect things to break. Everything is getting more complex. Everything in our lives, everything that we are building, we need to be able to adapt to it rather than just try and present an image of control that nothing ever goes wrong, because we all know things go wrong. We should understand the intimate reactions between people and technology. Don't isolate them as separate challenges. Don't see everything as a human error response or a system error response. Don't do that. And I think lastly, if anyone is familiar with Safety 2 thinking, this is pretty much what I was alluding to earlier. Promote what you do well. Sustain and grow a learning culture. And ultimately, hopefully, you'll actually start engineering resiliency into the systems that you build and the teams and everything you do. I just want to say thank you very much for the opportunity to present today. My slides are available right now at that address. So you're welcome to grab them, and yeah. Thank you.